Hello everyone and welcome on the testing stage. Thank you to the organizers who put this awesome event together and allowed me to talk a little bit about component testing in the browser. This topic has cost me a lot of long nights over the last 3 months, maybe more, because it all started with a lot of frustration I had when it comes to testing web components. The experience kind of sucked, and the way usually things are, if you are not happy with the status quo, you go in, you write some code that solves your problem, you open source it, and you show it to others, and maybe it helps others as well. So I hope in this session I can give you some insights about how you can break up your existing end-to-end tests into smaller chunks and really focus on the component level and keep your end-to-end test short and only for the most important user scenarios. Before we start, let me introduce myself real quick. I'm Christian. I'm a software engineer over at Stateful. We're working with some wonderful folks on a new concept called README Ops, where we try to bridge the gap between the developer gap between a developer and the projects. In addition to that, I'm maintaining the WebdriverIO project alongside many other awesome folks, and I'm a cross-project council member at the OpenJS Foundation, representing WebdriverIO there. In this session, I want to talk a little bit about component testing in the browser using WebdriverIO. And for that, we will start looking into what web components generally are, how you can test them, and how you can improve, how testing them can improve the stability of your test and increase your test coverage. We will look into the current tooling landscape, what they offer and what they don't. And then we look into how you can add WebdriverIO component tests to your project. I have some live demo prepared that we can look into. Lastly, I'll give you some outlook about what's next in terms of component testing in the WebdriverIO world. Let's start. What are web components? I wonder if you have heard the term before. Web components have been actually around for a long time. Some folks say that a guy called Alex Russell, who has been working at Google, has introduced the first concept in 2011. And actually not long later, Google has released a framework called Polymer, who has brought the first web component concepts into a JavaScript framework. At the same year, in 2013, Facebook has released React, which has taken the concept of reusable UI components using other implementation details. So the reason why all these new frameworks have popped up is because developers were kind of frustrated with the way they have been writing their monolithic JavaScript application. These code bases have been growing a lot, and it became more and more difficult to maintain them. So frameworks like React and Polymer have started to provide developers the ability to reuse UI components and compose the application with multiple different kind of UI components to make everything more clean and less code to maintain. So it's very interesting how over the years now, more and more UI frameworks have been popping up in the space, right? We don't have developers don't use only React and Angular anymore. They use frameworks like HTML, which is my favorite one, that provides a minimal interface on top of the web components standard that the browser implements. But there's more major frameworks like Svelte or Vue that kind of like allow you to opt into the web component experience with a just simple switch in the config. And we have to really differentiate between two concepts or two things here. There's one, the concept of reusable UI components, and that has been implemented through frameworks like React much earlier, before the actual standard, the web component standard, has been introduced by browsers and marked as stable. And the web component standards really consist out of like three. It's basically a set of specification in the HTML spec, and they define three different new elements or new interfaces in the browser. There's one, the custom element interface, that allows you to write a class that extends from an HTML element and then register it to the custom element registry. Then there's a specification on Shadow DOM, which is this encapsulated nested DOM that allows you to write CSS styles that only affect the web component and are not affect other elements, nor styles that can affect the elements within the web component. And then there are things like the HTML template, which is a concept that allows you to write HTML code that is not immediately rendered, but that you can take to inject it into something like a shadow DOM. So you can see on this slide a little example that shows everything like in detail. And basically it creates a custom element. It applies some styles to it that are not reflected to any other elements outside of the web component, and it allows you. It also shows that any styles outside of the component cannot affect the styles within elements in that component. And as again, writing web components does not require any framework, no bundler, no build tool, nothing. There are simple web APIs that you can use to create custom elements on the page. So there are then frameworks like lit-HTML that I mentioned before that wrap these interfaces into a little more usable classes. In this case, we have we extend from a lit element and have like a render method that allows us to write the HTML code within that JavaScript file. It makes it more convenient to write web components this way. But the underlying concept is the same. The underlying used APIs are the same. But then we also have React. It has been along for a long time. It allows us to write those reusable components in a different way. React does not, React is a tool that does not use web components under the hood. You can certainly opt into that, but they achieve the same concept in a different way by allowing you to write JSX, HTML in your, which is the same way of writing HTML in your JavaScript. And we use these components in multiple other areas in the world, in your application. And so, with front-end developers starting to build the application with frameworks like React or lit-HTML, they have kind of changed the way from writing monolithic JavaScript application using background.js to now like React, and kind of a lot of things that have changed in the front-end development space through that shift towards reusable UI components. Now, when those kind of shifts happen, usually, what people do is that they kind of like revisit other kind of like standards and best practices around developing application, including testing, to see if the current status quo still applies with this new concept shift. So we should do this for testing as well. Now that all the front-end developers built the application differently, maybe there's a different way how we should now test our applications. Which brings us to the next topic, which is called testing principles. And I think there's not one talk where I not include the testing pyramid in my slides. And for people who don't know the testing pyramid, it's a way to group software tests into buckets of different granularity. And I still fully agree with that concept. But I realized today it's kind of like very easy to get this wrong and get overwhelmed with the amount of different tooling that's available out there. I, for instance, feel very comfortable writing a lot of WebdriverIO tests, but this would cause the top part of the pyramid, the end-to-end part, to really blow up and basically blow up out of proportion. So as a tester and as a software developer, we should always ensure that we kind of like keep a balance between a good chunk of unit tests, a good chunk of integration tests, and just a small set of end-to-end tests to verify that all systems work together. Because writing a lot of unit tests is very cheap. However, they might miss some bugs when we integrate systems. However, end-to-end tests on the other side, they are expensive to run, they can be brittle, and they can be very costly. So we should make sure that we only write some of them, but the ones that we write will give us a lot of confidence that our application works as expected. Now, with the shift towards more UI, with the shift towards reusable UI components and the way developers build front-end applications today, we should also revisit the way on best practices of how we build, on how we test application. There have been folks like Kenzie Dodds who brought in this new concept of the testing trophy. And he tried to really emphasize the question of the return of investment of writing tests. Again, writing end-to-end tests, brings you a lot of confidence, but they're also very brittle and expensive to run. Where on the other side, unit tests are very easy to write, but they might miss bugs when we integrate systems with each other. So the idea of the testing trophy is really to put the focus on the integration level. And that makes totally sense to me, because it's a really nice middle ground between complexity, confidence, and the execution time. Now let me explain this in an example, right? Let's say we have a login form, and that login form, you put in your user credentials, and it makes a request to a backend, which is connected to a database. And I think every one of us has been writing an end-to-end test for those kind of scenario, right? And that is still valid. We still want to make sure that all these systems work together. But the scenario of a login has so many details in it, right? What happens if the user has the wrong credentials? Do we show the right error message in the UI? What happens if the backend is down? Do we properly show an error in the login form? Things like that. On the other side, what happens if the user tries some SQL injections? Do we really have like a system, and do we really is our backend breaking in those kind of scenarios? And then also, let's say we're writing this application, this login, is for a mobile web app. And our customers usually or mainly run or use this application with an iPad. So I don't think we would write just a ton of end-to-end tests to really validate all these details. So what we can do here is, instead of writing end-to-end tests, we just break all these tests down into smaller chunks. So we will focus only on the UI component, the login form, to validate if the UI changes based on the responses that we get on the backend. We can really focus only on the backend to make sure that the requests that get in are handled in a right way. And we write some end-to-end tests at the end that just make sure that the connection between all these components, that the connection is valid, and then all these system components can work together. So here we write mostly integration tests using component testing for the UI, API testing for the backend, and then just a small amount of end-to-end tests that, for a valid user scenario or invalid user scenario, that just checks if these systems can connect with each other. So you might say, okay, Christian, that sounds great. I will break up my end-to-end tests and try to write more component and integration tests. But where do I start? Which tool should I use? It's the ever-daunting question of what's the best out there. So let's look into the tooling landscape and see what's out there today that allows us to do more component tests. If you have been, usually good approaches, depending on what you're using for your front-end development, you go to the documentation page of that framework and you check it out what they have. So I did that for React, for instance. I looked into the old React docs and they suggest you a tool called Jest that provides you to render your component into an emulated browser with JS DOM. The new React page has actually no page about testing at all, which is funny. So hopefully they will add something soon. Other frameworks are a little bit different. They have, they have clear documentation about what you can use for unit tests, for component tests, and for end-to-end tests. Now, the common pattern among all these frameworks, though, is that they all currently, recommend you to use something called JS DOM. For folks who don't know what JS DOM is, it's a pure JavaScript implementation of many browser standards, notably the WebdriverIO DOM and HTML standards that to be used within Node.js. So it basically emulates a web browser in Node.js. And it's meant to be used for testing purposes. Like the project says, it emulates enough of a subset of a browser to be useful for testing. But using JS DOM today for UI tests is kind of like using an old Macintosh for graphics work, right? It kind of works, but it's not the ideal solution out there. Because there are a lot of common known caveats using JS DOM. There's things like missing web APIs. There's no ESM support, no support for fetch APIs or cores. The way to interact with elements within the JS DOM happens through JavaScript events, which is not really the same as interacting with an element through a real browser. And I will show you some examples in a second. There are problems with canvas. If your UI elements use canvas, there's problems to use that. The web APIs implemented in JS DOM might behave different than, for instance, in a real browser, for instance, in Safari. And there's no way to test things like pseudo states. So I've seen a lot of front-end teams that ended up writing UI tests using JS DOM, where they basically just render the component and validate if no error has been thrown. But they don't really test the interactability of the element. They don't really interact in those tests, in these tests with elements, because they were not really seeing any ways to do that. And if you have been using frameworks like Jest or Vitest with the testing library, which is a helper tool to render elements on the page or into the JS DOM, you might have experienced something like that, where you have to scroll through a blob of DOM nodes to debug the state of your application, which is not really good developer experience. And again, testing using JS DOM to interact with elements in an emulated browser is not really the same as using in real browser. Let me give you some examples here. Let's stay with the login component, with the login screen, right? That login screen has an input and a button to submit. What happens now if if our web component for some reason adds the CSS property visibility hidden to that component? Can we still click and interact with the element? Well, in the JS DOM world, yes, because the events are fired to the element, and it doesn't matter for JS DOM if it's visible or not. Other tools such as WebdriverIO, they are based on a web standard for automation, which ensures which makes sure that the element is interactable before clicking on it. Other frameworks like Playwright or Cypress, which have a different way to automate browser or browser engines, they also have those kind of security or interactability checks. Visibility hidden, same with height 0 pixel, is possible to click an element with a height of 0 pixel in JS DOM, not in other tools. Another use case is what happens if another element is on top of the element I want to interact with. Same here, JavaScript events still can be applied to that element, which a normal user could not do. Very interestingly, I tested a scenario where I moved the element completely out of the viewport in a way that the user could not bring it back by scrolling, for instance. So here I found that even tools like Playwright and Cypress have a really aggressive way to bring that component back into the viewport in a way that the user would not be able to do it. So it shows that here the WebDriver-based frameworks such as WebdriverIO are really have a good check and are really acting as a user would do, which is what you want, right? You want to have the test case environment as close to the real world as possible. And then there are features that are not supported in certain environments. There's some scroll action that you might have, that you might use to display different elements based on the scroll height. Those are not supported in JS DOM because there's no viewport to be scroll in. And then if you write mobile web components where you use multiple fingers to have some interactive scenarios with an element, those can be currently only toasted with WebDriver-based tools like WebdriverIO because WebDriver standard provides a really powerful Actions API. Lastly, there's a mocking component and aspect to it. I feel mocking is a very important feature that allows you to mock out either a dependency or a module to be not included in your test, and you give it a behavior that you would expect it to have. This is a very powerful feature to make sure that your component tests are not getting too big and are encapsulated and focus only on the code and the UI parts that you're interested in. So in this example, for instance, I mock out the Agoya search dependency and give it a behavior that I would expect it to have for my test to run a valid scenario. Now, you might now think, okay, this sounds all great. I guess I will get started with adding WebdriverIO for doing component tests in my project. So let me show you how you can set this up. The one command that you should remember is the npm init WDIO at latest. This will start a configuration wizard for you that will help you to get everything set up and running immediately. Once the package is installed, it will ask you a bunch of questions. For one, whether you like to run your test in Node.js or in the browser. In Node.js, you would do this for end-to-end test. In the browser, you want to do it for component test. If you select component or in the browser, it will ask you which framework you're using. If you use React, you pick React. Then it might ask you if you might want to use the testing library, which is a great additional tool that helps you to stage your tests and clean up afterwards. And then the further questions are pretty similar to what you used to when you would set up WebdriverIO tests, which is, where are your specs located? Do you want to use any plugins? And after all, it will install all the necessary dependencies and will create some example components and an example test that help you to understand where you can write your tests and that help you to get started very quickly. And then you can see that the example component test passes, and you can get started from there. In this example, we have been using a headless browser. However, if you decide to open up an actual browser, you will see this experience. You will see the web component being staged on the left side of the browser, only the web component, not the whole page. And then you see an HTML reporter in the middle. And on the right side, you can open the DevTools. And with running WebdriverIO in the browser, you can now access the WebdriverIO API in the browser as well. So you can see here that I try to find element within the consoles and validate if my commands work. And then I can pretty much copy and paste these snippets into my test and run them there. And what's very useful about this is that it really helps me to kind of debug my test, to fiddle around with commands and find selectors, for instance. WebdriverIO has an accessibility selector that allows you to fetch an element by its accessibility name. And the DevTools has an accessibility tab. So to find elements, you can just go to the accessibility tab, see if the element has an accessibility name, and copy it into your selector and validate if the element is there or not, which is really effective and helps you. It's a great experience to find elements this way. But enough GIF examples. Let's go into the real live coding part of the talk. And for that, I switch back into my VS Code. And you can see here I have set up a project, and this project has a bunch of templates for different frameworks. Let's pick React for this example. And the React project has a simple login component that is the same component as you've seen in my slides. It has a CSS file, and when you hit submit, it uses the login method, which is wrapped in this API.ts. And this pretty much just makes a fetch request. This can be anything else in your application. If you're using an authentication provider, that could be that. And for the example purpose, it's just here a simple function. And then I have a WDIO config that defines the browser, that defines the execution environment to be in the browser. I've defined React as a preset because I'm testing a React component, and I run my test headlessly unless I provide the debug flag. So let's get started and write a test for our login component. So we do this by, let's say, saying demo.test.tsx. And let's start with just testing stage demo. Should test my component. Let's start by just validating that we're actually running in the browser here. So the way we could do that is by using some of the browser APIs that are available, for instance, window navigator user agent. So let's just print out the user agent, and we go here, we run this, and we suppress all the errors, all the log messages aside from the errors. Let's run this. And this will spin up a headless Chrome and will now, show our user agent. And I can go in and say, all right, now I want to not test in Chrome. I want to instead use Firefox, and instead of Chrome driver, I switch to Gecko driver. And let's run this again. This now runs Firefox, and we see now that we get a Gecko user agent. So we can basically, use any kind of browser. We can even connect to a cloud vendor if we, for instance, don't have Safari installed in our CI and want to run our component test in Safari as well. So that's all possible. Now let's actually, test our login component by importing it from our login file. And in order to inject the login component into our page, I recommend to use the testing library because it has some useful functions like render, which you can use to bring in the component into the browser, and it automatically gets cleaned up afterwards. So we render our login component right here. And so in order to see what we have rendered, we just set a breakpoint by using the browser debug command. This basically just stops the browser there, and we can see what has been rendered. So let's run this, and let's enable the debug flag so we can see the browser. So this should now pop up the browser. I will bring this a little bit better up here. Now we see the component being rendered in the browser. We can open the DevTools. We increase this in size, and we move some of the logging here. And now we can start, working on our end-to-end test. We have the WebdriverIO API here in our console, and we can see we get the title of the page. So let's start writing some end-to-end tests, some component tests for it. We can inspect the element. We have an input here. As I mentioned before, we can now access the accessibility tab. It says that this element has the accessibility name email. And so we can just copy that into our console and say, okay, find me an element that has the accessibility name email, and set the value to hello at testing stage.com. So that works well. We do the same for our password right there. And then let's just click on our submit button. And that submit button has the accessibility name login. And as you can see here, a request is being made to an API, and it returned with an 400 because my credentials are not correct. But this is a good start. You can now write an assertion right in here where we say, okay, we expect now that our password element has a class name that is called, let's check what class name we added to this. So we have a class name isInvalid that we can use. IsInvalid. To have class name, let me just verify it in the docs. In our API, we have a docs around expect assertion to have element class. This is what we want to use. To have element class, so we place this, and that passes. That doesn't throw an error. We can just double check. If we say not, this should throw us an error. There we go. So perfect. We can now use this and basically copy all that into our test. Right in here. Okay. We remove all that and that and that. And this is our test. Now you can see I just saved my file and it runs the test and it cleans up the component. We still see this request being made, which we don't want because we want to not include the backend for our component test. We only want to focus on our UI component. So let's mock out our backend call and write a test that does not include our backend. For that to work, you can import a mock function from the browser runner. And what this mock function does, it's basically the same as you would use v.mock or jest.mock. It allows you to define, in a module or a whole dependency and, provide a mock for it. So in this case, we want to mock the API module here. We don't want to make the calls to the API. We could also mock on the fetch level. So we can say mock the fetch method and return a response that I expect. But that would, do this for the whole. This would do this for the whole browser. In this case, I only want to mock my API out, and we can see that our API module exports a named function called login, and so we need to provide a replacement for that. So here we apply a function that returns an object with a login property, and we want to replace that object with a mock function, and we want to say, okay, mock rejected value, like we want to return a promise that gets rejected with an error case, or let's say with a successful case. In this case, let's say, or not, let's do error, with an error, oops. So let's run this again. This time we add the watch flag. And you now can see that the test is actually erroring out for not having this valid. Just let me double check. It should click. It's now not making the request anymore. If we check in the network call, there's no request being made. But also the error. Yeah, that should be actually. Oh, it's a rejected value. Okay, mock response value, resolve value. So we not want to have it fail. We just provided like this API expect to be run without an error, and this would be the way to mock out and create an error case. In this case, we return a resolve promise, but with an error value. And in this case, we can test the component without having the backend involved. Now let's test a valid case. For that, we want to import our login from the API. And this will get us not the actual API module, not the actual login function, but it will give us the mocked instance of it. And we can just copy this out, create a new test. And before we run the test, we can say, for type purposes, I need to have mocked here. This is also similar to jest invite test. We can say our mock function login. Now returns the right response that we expect. Let's say a token, 1, 2, 3. And now we expect our area path or password input to not have a class called is valid. So we run this, and now let's should test a valid case, a valid login, and should test an invalid login. Just provide better test names, and now we can see, the tests are run. No HTTP request is being made because we mock out the API, and we can now really focus on our UI component to test all the details to it. So that's one thing I wanted to show: how you create your test, how you write your test, how you can mock out certain properties. Another thing that WebdriverIO provides is the test coverage reporting. Test coverage reporting can be very useful if you want to validate that you test, the whole component and not just like a certain part of it. We want to make sure that we really test all the cases and all the complete implementation of our web component. So for that, you can add a coverage property to your browser configuration, browser runner configuration, and you just say enabled true, and this will enable test coverage reporting. Now you can say set certain thresholds to say things like, I want to make sure that I have tested 100% of all the code lines of my modules. So in this case, you can define your lines to be tested 100%. You can add branches, functions, the usual test coverage options are available to you here. We now say, for now, for the demo purpose, we say lines. I want to test all my lines. And just run this time without the watch flag. Just have one simple run. It opens up the browser, executes the tests, and now I see, my tests are passing. That's great, but I didn't match my coverage threshold, which is for lines 93%, but I expect it to be 100. So we can go in and say, okay, let's have a look into the coverage report. We can we can open up this and we can open this up in the browser. Let me just open this in here. 1 second. Brings us right in. Localhost 8080. So we can just start up a static server that prints out our report, and we now see that we are missing one line, which is the case when no email and no password is provided. So let's make sure we cover this as well. Let's go into our test and add another test case. Should test an invalid login with missing credentials. Here, it doesn't matter what our backend returns because we don't submit after all. We don't make the request after all, or we don't use the API after all because the click doesn't happen. And now we expect our password to have the class invalid because there's no value in it. So let's rerun this. There we go. We can remove there. Don't need to see the browser. So this now runs 3 tests, and voila, all our coverage is now reported. We can go back to verify this. 8080, open up our browser, and we see that our coverage report now, our test now covers that specific line. All right, let's go back to the slides. Right here. So that was a demo. I covered again how you write your component test, how you really make sure that you only focus on the component. Don't use the backend. It's really nice to have just the single component injected in the browser, test all the different kinds of scenarios. You can work with the component and mark everything out that is not needed for that that's not needed and used in your for your component. So what's next in terms of component testing WebdriverIO? We are looking into some more enhancement to the mocking capability. We have some known issues. For instance, testing multiple browsers at the same time doesn't allow you to use mocking at the moment, but we're trying to fix that and address this. We want to add more support. Want to allow you to use Jasmine or Cucumber for your tests, for your component tests as well. We might add a new feature for snapshot testing, which means that you can, create a snapshot of the whole DOM tree of your component and kind of like with that validate a lot of different kind of details like class names and IDs and other properties with just one single assertion. We want to add more support for frameworks like AngularJS. You can test basically everything in the browser with WebDriver already, including AngularJS applications and modules and components. But we want to provide better support for it by adding presets and documentation. And then whatever else, you can give WebDriver component the browser runner of WebDriver a spin And if you miss any features or want to see, experience any bugs, just report it, and we can get this sorted out. With that, thank you so much for your attention, and I hope this was insightful for you. I'm happy to answer any questions.